Thank you for using the track parser. This tutorial on the track parser will show you how to use the track parser and get the data from your track. First, when you're out in the field, track your climb or run, mountain bike ride with whatever device you typically use. Garmin watches, the CalTopo app, the Gaia app, or any one of the number of apps and devices that allow you to track. With the track, you're first going to have to download it onto your computer or tablet. There's a list of devices that work as far as their tracks are concerned. Some tracks unfortunately don't work. For instance, the unpaid version of Strava doesn't come with timestamps on your track points, and the track parser needs the timestamp to parse out your track to let you know how long each leg took. Here's a list of devices that do work and the file formats that work. To give you an idea of the file format, for instance, CalTopo, you can export your track in 3 different file formats: GPX, JSON, or KML. When you download from the CalTopo app the KML, it does not come with timestamps and will not work, but the other 2 file formats will. So this is not an exhaustive list, but a pretty solid list of the types of things that work. So I have a track that I did climbing the Damnation Buttress that's here, and that's the track we're going to use to parse. So first thing I'm going to do is go to the track parser and click this smoothing part, which will bring you to this page. And then I'm going to choose the file that I want to smooth and upload it. This will take a few seconds, but pretty quickly you'll come to this download page. And what you want to do is download that smoothed track. At this point, what you'll find is you'll have 2 files in that folder. You'll have your original track and then this JSON file that is the smooth track. At this point, what you want to do is go to CalTopo and import both those files. So I'm going to just import both of those. And this is the track of my day climbing the Damnation Buttress from Pinkham Notch. At this point, what you'll notice about the track is the first section is kind of a there and back. In other words, we use the same trail to approach and descend for a good part of the way. That adds some complexity to the track, and so we're going to start with putting the waypoints in so that you can break up your track and deal with that initial complexity. What you want to do is make sure your track points are actually on the right part of the track. Now, the smooth version of the track has arrows, so you know which one was up and which one was down. So what I'm going to do is I'm going to add a marker and put it at the start of the up track. And I'm going to name it. I'll just name this simply start. And now what I'm going to do is in the comments, I'm going to number that track or that waypoint as the first waypoint. I'm then going to decide where I want to break up my first leg. And there's a kind of a natural place to break the leg on this route, which is right here at this trail junction. Now, what I want to do is make sure that I do hit the up track. Now, when I place this marker, it's important to place it correctly. If I place it someplace like this, right on the kink of the yellow line, which is my smooth line, I'll unclick the original track so it's a little bit clearer. The track parser will pick up that track point, which is the upward track point. If I pull it a little further over and into this spot, what you're going to find is that there's a chance that the track parser will pick up the down track point, and that will throw an error. And that error will tell you that this track point or the next one is in error, and you need to replace it so that it's actually on the right spot. So just make sure that you're on the up track and at a point where the track has a kink. That's where there's an actual data point. And now I'm going to put trail. I'm going to make this nice and simple. I'd probably put Huntington Ravine Trail. What you label it is up to you. And that's track point 2. And then I'm going to space out my track points or my waypoints quite a bit for this tutorial just so you can see. But obviously another good place to put it might be at this junction. It depends on how you want to break it up. What I'm going to do is go all the way to the floor of the ravine. Now, at this point, I know that we stopped at the floor of the ravine to gear up. We had to put our harnesses on and our crampons and so on. But it's hard to see on the smooth version because when I put the original track in, what we're going to see when I zoom in is the spot in which we stopped. In other words, you can see there's a lot more, the line sort of bounces around the original line. And the reason for that is because there's slight error in your location with the GPS, and that bouncing around is where we stopped. And so if I want to get an idea of how long we stopped at this point, what I'm going to do is put a waypoint right at the start. And you can see the start has a nice kink right where we stopped. So I'm just going to put transition. And I'm going to use a little code. In other words, a little phrase. And I'm going to put it in parentheses. I'm going to say fix stop. So what this does is it removes any distance and elevation gain of that dither so you get a more accurate portrayal of what you did. And this is now waypoint number 3. Now, on the other side, I want to know when we started back up. And unfortunately, the smoothing actually almost smoothed too much. The next point is almost 60 feet of elevation higher. And so I'm going to miss a little data. But for me, the stopping data is more important. And I know it didn't take us very long to do that 60 feet. So I'm just going to put start climbing. And start climbing up the fan. That's the area. And this is track or waypoint number 4. At this point, we approached. It gets a little steeper. The cramponing, you can see there's a lot of dithering of the original track, but fortunately the smoothing took care of it. And then you can see right here is where we actually started our ice climbing and our climb of the buttress. And because it took us so long, there's a lot of error in the original track. So I'm going to unclick the original track so you can see how much smoothing took place. And it's actually quite a bit. And what I'm going to do is I want to get an idea of how long it took us to do the initial ice climbing. So I'm going to go from roughly there, and I'm going to go ice climbing. And now I want to even get rid of more of the error in that track. And so I'm going to use another phrase, fix up. And what this will do is it'll clean it out to a straight line. And the end of the ice climbing and the start of the traverse, I'm sorry, I'm going to number this one number 5. Now the end of the climbing and the start of the traverse begins right here. And I'm going to highlight the original track again so you can see this was a belay spot, and then we left the belay spot and traversed out onto the buttress. So I'm going to write traverse to buttress. And this is waypoint number 6. At that point, what I'm going to do is go to the other end of the traverse. I'm sorry, I'm not going to do that. See, I don't need to fix the next section. I can go right to the top of the climb. Now at the top of the climb, I know we spent a little time right here on another transition. We took off our crampons, we put on micro spikes, and so forth. So what I'm going to do is I'm going to add another marker right here and put top of the climb, and I'm going to do another fix stop. And this one is, you can see I've got 6 waypoints there, so this is waypoint number 7. And then I'm going to start descent. And again, I'm going to go for a kink, which is a little ways away, so I'm going to lose a little data, but I'm going to get a good, accurate picture of how long that transition took. And I'm going to go start descent, and that is waypoint number 8. So once we started our descent, we went all the way, and the next main feature that we got to is the Lion's Head Trail. So I'm going to, or excuse me, the top of this descent gully. So I'm going to just go, that's where we join the Lion's Head Trail and descend down. We descended down what's known as Lobster Claw Gully. So I'm just going to add a marker there. And we just kept kind of moving through. We didn't stop. So I'm going to put top of Lobster Claw. And you can see that I keep both lines highlighted, but you have to remember that what the track parser is working off of is this smooth line. So that's where you're putting your waypoints on as close to the kinks as you need to. Now, because this isn't a there and back, I can almost put this anywhere. If I were to edit it and stick it out here, what track parser will do is just find the nearest track point. So you'll get fairly accurate. Where you need to be much more precise in your placement is on those sections where there's a there and back section. Now, this is, I believe, track point number 9. And then I'm going to go right to the floor of the ravine. Now I'm going to highlight the original track again. If I remember right, we sort of did we didn't really stop that long. We just took a photo. So I'm just going to kind of go bottom of gully, and I'll put that right there. And I believe we're up to number 10. Then I'll continue down and we'll put another one at Hermit Lake. And here you can tell we had a fairly large break. So what I'm going to do is put a marker right there, Hermit Lake. I'm going to do fix stop again. And the parentheses are important. On the label, the fix stop and the fix up needs to be in parentheses for the track parser to recognize it and fix the data. One of the fixes that we're not going to use on this particular track is a fix down. And you can use that just like fix up, only for rappels or down climbs that take a long time, and it'll clean up the data for you. So Hermit Lake, I probably should capitalize Hermit. And that is track point number, or waypoint number 11. And then I'm going to go start a descend from Hermit Lake. And that's waypoint number 12. And then I'll go down and we're going to get into that there and back section. I'm going to put another waypoint at the Huntington Ravine Trail where we joined it. And probably the best place, I'm going to unclick the original track here, right there. And I'm going to make sure it's on the descent right at that kink. And I'm going to put Huntington Trail. And I believe we're at waypoint 13. And then I'll go to the bottom, and that'll be our final waypoint. And that is the legs, at least I decided to do. You can break up the legs any way you want. You can make them longer or shorter. This was your trip, so if you have questions, I wonder how long that section took, or I wonder how long that transition took, or that rest, how long we stopped there for. You just put your waypoints on your track where you can get that data. And that is waypoint number 14. Now, let's just say, if you remember on the way up, I put a waypoint here. That was the trail, and that was waypoint number 2. And I had said, oh, maybe a good place to put a waypoint was here. And then I decided not to. And then now I'm rethinking it and I'm going, oh, I wished I had put a waypoint there. Well, with this numbering technique, what you can do is add a waypoint there. You can add that, and this is known as the fire road. So I'm going to put the fire road. And this is between waypoint number 2 and number 3. So what I'm going to do is call this waypoint 2.5. And I can use any decimal point at this point. In other words, if I wanted to put 2 or 3 waypoints between waypoint 2 and waypoint 3, I can use 2.1, 2.3, 2.7. I can, in other words, I have as many waypoints as I want can go in between, as long as the decimals are in the right order. So I'm going to add 2.5 into that spot as kind of a second thought, and to show you how the numbering works, so that way you can add waypoints or subtract them. If you subtract a waypoint, you don't have to renumber all the others. The track parser just goes to the next number, and it works on decimals, so it'll just go to the next decimal. It just sorts it by the next highest number. So now I'm going to export this. And what I'm going to do is I'm going to uncheck, and I'm only going to check the markers. Now, if you had exported it with all of the things checked, the track parser can differentiate between the waypoints and the tracks, but it's just you're less likely to have an error or run into some problem if you just simplify the file you export so that it's just the markers. And I'm going to export this, and you can name this, whatever you want. I'm just going to name it waypoints, just so I can differentiate where it is. And I'm going to save it to the same file. Now, the track parser, at this point, you want to parse your track. So I'm going to click on parsing. And what it'll ask you to do is resubmit your track file. So here I'm going to choose, and I'm going to actually resubmit the track file. Now, one mistake you can make is to resubmit not your track file, but actually submit your smoothed file. If you do that, there won't be an error. In other words, you can put either one. It's probably best to submit your original track file. Just simplifies things. But if you make that error, it'll be fine if you put the smooth file in and then upload that into the track parser. It'll then ask you to upload your waypoint file. Now here you've got to make sure it's actually the waypoint file that we had just exported from CalTopo. And now click upload. Now try to make sure you only click upload once. This takes a little while. It's getting data from outside sources, not just your track. It takes up to 30 seconds before you'll get to this page where it'll ask you to download your results. At this point, you download your results. It'll go, I have my browser set up to download in the same place that all the other files were, so it's nice and clean, and I get a results folder. On some browsers, you'll see the results folder as a zip file. You just open the zip file and you'll get the folder. Inside that folder is the data. So there's a couple of pieces of data. The CSV is for people who like to work with raw data in a CSV format, like in Excel or something like that. The main piece of data is this XLSX file. And I'm going to open that up in Excel. And here it is, the damnation buttress. And this is the data we parsed out. So one of the things you'll notice is you'll get weather data. You'll get about 5 weather data points in your route. It takes a while for the weather data to come in, so we can only get 5. So I have roughly 15 tracks, 14, 15 tracks. So it's 1 every 3 is what it'll end up being. And you can see on the summit of Mount Washington, it was 19 degrees Fahrenheit. And I don't have any wind data on that one. On the next one, it was 23 degrees Fahrenheit, and now I've got some wind data. It was 100% humidity, 36 mile per hour wind with a 47 mile per hour gust. And what you'll get out of the weather is location of the weather station, the altitude of the weather station, the date and time, and the distance the weather station is from your start point. And then here's another Mount Washington, and then another Mount Washington, and then finally another. So it's only pulling up from Mount Washington. More recent tracks, this was in 2020, more recent tracks, there is now, just for locals, a weather station at Hermit Lake. So some of your data will come from Hermit Lake. So now I'll just go over the data just so you can see. So you get your date that you did this track, the weather for the start of your leg, the start time, and this is corrected for daylight savings, etc. The name of your start place, that's your label. The starting elevation, the ending elevation, the altitude in feet of the start point, the distance you traveled, the time, the total ascent. I'm sorry, the starting elevation, the ending elevation, and the altitude change in feet between those 2 points. The distance in miles, the time it took you to do that, and then your total ascent and descent. And this first one is according to your GPS. Then there's the Munter rate for those who are interested in the Munter rate, and then another total ascent and descent, and that's according to a digital elevation model called the Shuttle Radar Topography Mission. So you may see some differences, 944 and 3, 1,099 feet and 111. That's because both data sets can have some errors. And so what most programs and things do is they pick a data set and then they say, this is how much you went up and down. This allows you to compare 2 data sets so you get a better idea, because all data sets will have some error, and elevation is where gain and loss over the course of a leg is where you're gonna get. There's no perfect data there. So it just gives you some idea of how close. So you can just figure it was roughly 1,000 feet and somewhere around 75 feet of descent. So about 1,000 feet up, 75 feet down. What your mile pace was, your speed in miles per hour, your direction of travel, the average angle of that leg, and then the distance between the start point and the end point if you were to draw a straight line. So we walked 1.2 miles, but the distance between those two in a straight line is 0.87. And then your end point and then your running time. So for the quick read, you can go from the start to the trail. Your altitude change was 941 feet positive. For 1.26 miles, took you 38 minutes to the trail. And then you go from the trail to the fire road, 426 feet of altitude gain, roughly a half mile, took you 16 minutes to the fire road. So you can read it in a loop without having to scroll, but if you want more of the data, it's there, and you can see your elapsed time throughout the entire thing. So that's one of your data points. Another one of your data points is you can unclick your markers and import from your file, from your results folder, this JSON file into CalTopo. Now this only goes into CalTopo, and what it'll do, I'm going to unclick the smoothed and the original, okay? And what you'll see is your trip broken up into legs and colorized the same color as your Excel spreadsheet. And so now when you click on the leg, you'll get some basic data. Okay, so from the fire road to the transition, the leg time took roughly an hour. The elapsed time was an hour and 52 minutes. And for that section, our munter rate was a 5. Okay, the distance you can see is 1.29 miles. Now, what's interesting is if you do this on CalTopo, you can then do a profile and get another actual, they use a different digital elevation model than the SRTM, and you get a sense of what your elevation gain and loss right here in the gross, 890 and then 22 down. So you actually get 3 different elevation models to give you your up and down. If you happen to be, as this map is, in a LiDAR area, that digital elevation model is probably the most accurate of the 3. Now your XLXS file, if you want, and you want to incorporate this, you can add a column, or you can just put that information into your XLXS file, because that's fully editable. You can edit that. Now every time you stopped, the color will turn red. So that's one of the fixed stops. And you'll see the munter rate is zeroed out, and your elapsed time and your time is accurate, but there's no other data. Like in your Excel spreadsheet, you'll see everything else is zeroed out because you were stationary according to your label. Now, the other thing to note is the fix up. Notice how this fix up, okay, changes that zigzagging to a nice straight line. And so you get only the data. So that we ice climbed at a munter rate of 1.3. It took us an hour and 3 minutes to climb. And then on the Excel spreadsheet, you'll see that fix up section, right, will zero out any descent. So we gained somewhere between 300 and 350 feet according to our SRTM data and our GPS data. And then it's always interesting to look at it from the point of view of CalTopo, and to see what we got there was 316 feet. So you can see you get those 3 data sets, which allows you to deal with any kind of errors in your data set and gives you a pretty good idea of the actual elevation gain and loss. Now, to continue on with the data set, if you're a Gaia user, the track parser will work with Gaia as well, but that JSON file that we put into CalTopo will not go into Gaia. The format doesn't work for Gaia, but this KML file does. The problem with the KML file is that the KML file doesn't have arrows on it. Now, Gaia will put arrows on it to some extent, and if you're a Gaia user, you have to highlight that leg to see the direction. For the legs, it's not that big of a deal. And so if you want to see the same data in Gaia, use this KML file rather than the JSON file. Now, what's interesting for Gaia users is the smooth JSON file, because it's only one track, does work. See, the problem with Gaia is it doesn't recognize the fact that there's a number of tracks in just one JSON file. And so what you want to do is you can do all the waypoints and everything in Gaia. The waypoints can be done in a JSON file, which is what I did, or a GPX file. And so in Gaia, it only allows you to download your waypoints as a GPX file, and you can do the same thing. Label those and put in your comments the number, and the GPX file will work going out of Gaia. Now, Gaia is more complicated to put your waypoints in and do the downloading, I find. And so if it's kind of 6 of one, half dozen of the other, in other words, you don't use either one all that much, I would defer towards the CalTopo and put your waypoints in CalTopo. All right, so we have this KML file, and this KML file can be quite useful if you have Google Earth on your machine. If you click the KML file, it'll default to opening up Google Earth, and it will put your legs onto Google Earth. Again, you'll see there's no arrows, but if you click the leg, you'll see that data. And so now you can see your data in sort of a more 3D version. Get a sense of where the stop was, where the climb was, the traverse, the buttress section, and by clicking on, you get an idea of the leg time and the elapsed time. And so that KML file is useful for Gaia users, and it's useful to import your data into Google Earth. Now, finally, there's one more bit of data. And for climbers, this may not be as useful. It's kind of interesting for trail runners, mountain bikers, is this HTML file. If you click that HTML file, what you're going to find is it'll open up your browser, a map, and now you have a heat map. And this is a speed heat map. So kind of the red sections are where you're going slower and so on. Now, this is of the smoothed thing. It's not broken up into the legs. If you zoom in, you'll see each individual track point, and if you bring your cursor to a track point, what it'll do is it'll tell you your speed in miles per hour from the last waypoint or from the previous waypoint. So we were going 0.23 miles per hour, and that previous waypoint, this one, was 60 feet away. So that one, between this waypoint and that, we were going almost 1 mile per hour, and that we traveled 38 feet. So you can get an idea of like your speed. So for instance, here, what you'll notice is our speed is much faster because we were just hiking down. Probably took a picture there, so there's a little bit of a slowing down. And our average speed was, somewhere around 2.5 miles per hour or so as we were crossing the Alpine Garden. And so for trail runners, for mountain bikers, just as a general rule, you kind of get an idea of your speed, and your track is mapped. And so for the descent here, you can see we were going about 1.5 miles per hour, maybe a little bit slower on average as it got a little steeper. You're doing pretty good. And then as we started down towards Hermit Lake, our pace picked up and you get a better sense. We're going downhill now. So now we're going almost at 3.5 miles per hour. So that HTML file, it won't work on a phone. It won't open up the HTML file. The phone won't. But and I'm not sure about a tablet, but it does work. Here I'm using a laptop. And so that's the data that you're getting from the track parser. So some key points. One, import your track into track parser and smooth it. Put both the smoothed and the original track into the track parser and place your waypoints along your smooth track at the kink points, particularly on there and backs, and name them, and then in the comments, number them. Do that through your entire track. Export your waypoints. Go to the parsing section of the track parser. Resubmit your original track. Then submit your waypoints and download the results. If the track, because you were going slow, zigzags and bounces up and down, this happens on climbs, use the phrase fix up at the start of the climb to straighten that leg out. If it's a descent, use the phrase fix down to clean up any rappels. And for transitions, for ski touring transitions or stops and breaks that you want to get the data for how long it took, use the key phrase fix stop. And all the fixes need to be in parentheses and they're part of the label. So they'll show up in your Excel file as either a fix stop or the fix up. I hope you enjoyed this tutorial, and I hope the track parser gives you some good information about your trips. If you have any problems with track parser, my email is on the track parser pages. You can contact me and I will help you with any problems. And if I find that there's a bug, because your problem highlights a bug, I'll do my very best to fix it and get you the data. Thank you very much.